Hello everyone, my name is Aliyev Shamil and I am from Shamkir, west city of Azerbaijan. Shamkir is very famous for his greenhouses and farming. Basically, that's the place where many problems appeared in recent years. Farmers spend months growing their products, and when they finally bring them to the market, when they bring them to Shamkir Sabati in order to sell it, that's the place where every problem starts. If they're not going to be able to sell their product in one day, the price is going to drop. If they're not going to do it tomorrow, the quality of the product drops. If they're not going to be able to do that in 3 days, everything is going to be spoiled and rotten, and they're going to lose their money again and again and again. Standing on bazaar every day and seeing this scene and all the unfairness that were happening there, it just didn't feel correct. A simple question was asked: why the person who actually does the hardest job have the least control? That's how a caravan appeared.
So what is a caravan? From the farmer's side, it's simple. You upload your product, add a new photo, set a price, choose your location, and now it's there, visible. From the buyer's side, it feels like a normal marketplace. You scroll, you search, and when something catches your eye, you just open it and message the farmer directly. No middle step, no middleman. Everything is simple. And that chat part matters very most, because real deals don't happen in one click. People ask, negotiate, figure things out, talk about the price, talk about the quality, and when everything is done, and once they agree, delivery is already inside the application. So everything stays in one place. A caravan brings all main participants of the agricultural market into one digital system. It starts with the farmer, who adds fresh agricultural products to the platform and offers them directly to buyers. The buyer or dealer can search for available products, check details, and communicate with the seller without depending on middlemen. Delivery is also part of the system. Logistics companies and drivers help move products from farmers to the buyers, from point A to point B, making the process more organized and transparent. To keep the platform safe and controlled, admins manage users, products, and system activity. All these users work through two main applications. Farmers, buyers, logistic companies, and drivers use the mobile application, which is built with React Native and Expo. Admins and moderators use the web panel, which is built with Next.js. Both applications are connected to the same backend. This backend is the main brain of a caravan. It is built with Java Spring Boot and handles all requests coming from the mobile app and the web panel. The backend uses REST APIs for communication, JWT and Spring Security for authentication and access control, and WebSocket with Stomp for real-time chat between users. Behind the backend, the system uses PostgreSQL hosted on Neon to store users, products, messages, and logistics requests. For product images and media files, a caravan uses Cloudinary. In this way, every part of the platform works together. Users interact through the apps, the backend controls the logic and security, and the cloud services store the data and files. As a result, a caravan becomes one connected ecosystem for farmers, buyers, logistic providers, and administrators. In this part, we're going to explain how a product listing is created and published in a caravan. The process starts with the farmer creating a new product from the mobile application by entering details such as product name, category, quantity, price, location, and description. Before the listing is accepted, the backend checks the user's authentication token to make sure the request comes from an authorized farmer. After that, the farmer uploads product images. These images are not stored directly in the database. Instead, they are uploaded to Cloudinary, which stores the media files and returns image URLs that can later be shown in the application. Then, the product information is sent to Spring Boot backend through REST API request. The backend validates the required fields, checks whether the data is correct, and connects the listing to the farmer's account. The structured data is stored in PostgreSQL. This includes the product details, farmer ID, product status, location, and the image URLs received from Cloudinary. Basically, each text format data. Once everything is saved successfully, the product status becomes published, and the listing appears in the marketplace. Buyers can then open the product page, view the images, check the price and quantity, and read the description. From this point, the buyer can either start a real time chat with the farmer, call him by his phone number, or request logistics if delivery is needed. So this flow shows how eCaravan connects authentication, REST API communication, backend validation, PostgreSQL storage, cloudinary media handling, and marketplace visibility in one complete product publishing process. Thank you very much.
Now I explain the main technical challenges we faced during the build process of eCaravan. The first challenge was that the multi-row system we had. eCaravan supports several rows: farmers, dealers, logistic companies, drivers, admins, and each row has different screens, workflows, and permissions. To avoid duplicated user logic, we implemented row-based system basically. And what happens there is that JVT token understands that the person logging in is, for instance, the dealer, and based on this, it shows the screens that corresponds exactly to the dealer and gives the permissions corresponding exactly to the dealer. The second challenge was data and media separation. Basically, eCaravan supports several media files. It can be images on avatars, it can be images in listings, it can be images and videos anywhere else. All of this should be stored somewhere, and storing it on a database will look like this. Imagine that this is your database, and if we put heavy files into it, it will not fit. So basically, you see, it's overflowing. I can't close it. So what we did basically is taking the Cloudinary service, which stores files, and putting the links into the database. And by putting the links into the database, we manage closing this database. It manages these sizes. So, and the last problem is basically the messaging, instant messaging. First, when we saw this problem, we saw that we will need to connect Firebase, because Firebase provides us with better solutions for this kind of instant messaging. But what we found after deep research was WebSockets with Stomp. Basically, we had WebSockets before, but we didn't know about the Stomp. And by using Stomp, we basically get that instant messaging. You do not need to refresh the application every time. You just take it and you start the messaging. It opens the socket and everything is delivered to the right place. So it's secure, first of all, it's reliable, and it's instant. What's the main thing basically?
Would like to take you through the behind the scenes of our project, which is called eCaravan. So one of our first focus areas was aligning our solution with the daily needs of farmers. Initially, it was a bit challenging to establish a constant line of communication with them because of their busy schedules. So to keep the momentum going, we began building the application based on our own research and initial observations. So, however, when we shared our first prototypes with the farmers, we realized there was room for better alignment. The feedback was incredibly insightful, and they pointed out specific operational needs that we hadn't fully captured in our first version, actually. So instead of seeing this as a feedback, we viewed it as a valuable opportunity to pivot. We took those lessons to heart and adjusted our design to ensure e-caravan truly serves the interests. It taught us that in a project like this, the user's voice is the most important compass in this way. So on the technical side, we also had an interesting experience with team synchronization. Our team uses a mix of Windows and macOS environments. We noticed that sometimes moving code between these systems lead to minor dependencies, adjustments, and setup variations, unfortunately. While these technical nuances took a bit of extra time to harmonize, they were actually very beneficial for us.
I'm extremely sorry to interrupt. However, at this point, I guess it's time to explain the feature that we're very proud of. This feature is mapping and route visualization for logistic companies. This functionality is very important since ACAR1 was sought to be not just a simple marketplace where people can list their products and just sell them. The main goal of our application was to optimize the agricultural chain system. And for this, geolocation, the direction, your position is very important. Buyers need to discover the products around them geographically since we have implemented sorting and buyers can see the products that are listed nearby them. And logistic companies need to understand the direction, the location of point A and the location of point B that they're going to be transporting the product or any other stuff that it's going to be sold in our application. Technically, we implemented mapping in both mobile and web panel. In mobile, it was made for farmers and dealers or buyers, let's say. Farmers are putting the location of their product, of the location where their product is. Coming to web panel, it was implemented for logistic companies. Logistic companies are taking a look at the point of the farmer, the product where it's located, and since the buyer is actually sending a request for the logistics system to make a transportation, they need to understand the route, the condition, the distance, and everything. And that's why it was implemented for them as well. And if they accept the request, if they approve it, automatically they're going to be able to see the route from point A to point B. They will be to see the detailed information of the buyer and also the seller. So how we implemented this, let's get a deeper look at this.
An important mapping feature is the marketplace map view. In the market screen, we implemented two ways to browse products. First is list view and second is map view. In list view, products are shown as normal cards. In map view, the same products are displayed as markers on the map. The important technical decision here is that the map view does not use a separate product system. The marketplace keeps one shared product state, and when the user searches or applies filters or changes sorting, let's say, the app sends a request to the backend and receives a filtered product listing. That same results are used for both for list view and for map view basically. For example, if the user searches for tomatoes, then switches to the map view, only tomato listings will appear on the map. If the user selects a radius filter such as, let's say, 10 kilometers, the app sends the user's current latitude, longitude, and selected radius to the backend. Then the backend returns only products within this distance. The app also supports user location using expo location. If permissions are granted, the map centers the buyer's real GPS location and shows the user's position. Each product with saved coordinates appears as a marker, and tapping the marker shows the product title and price. And then, if you tap on the callout, which opens after the previous step, then the product's detailed page will open. So this feature turns our marketplace from a simple list of products into a location-aware product discovery system. This is very important when you are trying to find products near you or in different cities or even in different countries. Buyers can not only search by category or price, but also understand where products are located geographically, basically. Now, I want to show how location is used inside the product detail page. When a user opens a listing, the mobile app first fetches the product data from the backend. If that product has saved latitude and longitude values, the application does not only show the text address, it also renders a small map preview using React Native Maps. This preview is intentionally read-only. The users cannot accidentally move the map or change the location. It simply shows one marker at the product's saved coordinates. Under the map will also show the address text, so the buyer can understand both the visual location and the written address. At the same time, this feature removes the possibility for the users to just pick Azerbaijan or Baku as their address, as it's done in several different platforms like Tapas. If the buyer wants to inspect the location more clearly, they can tap the map preview. Then the app opens a full-screen map model centered on the same coordinates. In that model, the marker contains the product title and address. Technically, this feature is simple but important. The backend stores the product's latitude and longitude in the database, and the frontend reads those values from the product API responses. So the map is not manually drawn or hard-coded, it's generated dramatically from the product's real stored coordinates. This makes the product listing more trustworthy and the map render more efficient because the buyer can see where the product is actually located before starting communication or requesting logistics.
One of the mapping features we're especially proud of is the route visualization inside the logistics web panel. At this stage, the product has already passed through the earlier parts of the system. The farmer has created a listing and selected the product location. Later, when the buyer requests delivery, they choose the destination point. So when the logistics company opens the order detail page, the system already knows two important coordinates. First one, where the product should be picked up from, and the second, where it needs to be delivered. And this is where the route map becomes useful. Instead of showing the logistics company only written address, we show the delivery path visually on the map. And sending the location or geoposition via WhatsApp chat is not needed anymore. Technically, this is handled by our route map component in the Next.js web panel. The component receives 4 values from the order data. This is pickup latitude, this is pickup longitude, this is destination latitude, and destination longitude. Once these coordinates are available, the frontend sends them to open source routing machine. OSRM uses OpenStreetMap road data to calculate the real driving route. This was important for us because a straight line between 2 points is not useful for delivery planning. Roads, turns, and distance matter very most. So instead of drawing a simple line, OSRM returns the actual road geometry as GeoJSON. After that, our web panel reads the GeoJSON data and draws the route as a polyline on the leaflet map. We also place one marker at the pickup point and another marker at the destination point so the logistics company can clearly understand the start and the end of the delivery. OSRM also gives us the route distance in meters. We convert it into kilometers and display it on the order page because distance is one of the most important details for logistics planning. Another detail we handled is automatic map filtering. The map adjusts its zoom and position so both markers and the full route are visible without the user manually zooming out. And because Leaflet depends on browser APIs, while Next.js can render pages on the server, we'll load this map component dynamically with server-side rendering disabled. Eventually, from the user's point of view, they simply open an order and see the route. But technically, this feature connects database, coordinates, and order workflow, OSRM route calculation, GeoJSON processing, leaflet rendering, market placement, distance calculation, and Next.js client-side loading into one practical logistics tool.
Since we have finished discussing the mapping system and you fully understood how the architecture and which tools we used in order to implement that function, yet we have many features that we would like to talk about. However, one of the most outstanding was again database and the structure of database. Till now, you would already guess that we used Neon and Cloudinary. However, how they were implemented, in which structure they were implemented, we didn't discuss it. So I guess it's time to do it since we had many problems with this, as Namik already told, and we want to show how we did it.
The first part of the database is the user and authentication domain. The main table here is the users table. This table works as the central identity table for the whole system. Every type of user is stored here, including farmers, buyers, logistic companies, drivers in the future, admins, and moderators of logistic companies. The table stores important information such as the user's phone number, full name, email, password hash, account type, profile photo, and notification preferences. A very important detail is that the phone number is used as a unique login identifier. The password is not stored as plain text. Instead, it is stored as BC crypt hash, which is much safer because even if someone accesses the database, they cannot directly read the original password. Role user, role admin, role moderator, role logistics, role driver, and role owner. Most of them include nowadays in the A-Caravan application. Some of them are planned for the future. These roles define what each user is allowed to do inside the platform. There's also a password reset token table. This table supports the forgot password flow. When a user requests a password reset, the system creates a temporary OTP token with an expiry time. This allows the backend to verify that the best and the reset request is valid and time limited. Coming to marketplace and chat domain, this is where product listings, product images, conversations, messages, and notifications are handled. The main table here is products. This table stores all marketplace listings created by farmers or dealers. Each product has a custom primary key in the format of PRD XXXX instead of normal auto-increment ID. This makes product identifiers more reliable, more readable, and more suitable for marketplace usage. The products table stores details such as product title, description, price, category, quality, quantity, address, latitude, longitude, status, and all other things. The latitude and longitude fields are very important because they allow the system to support location-based search and map-related features. Each product is connected to the user who created it through a many-to-one relationship. In other words, one user can create many products, but each product belongs to one seller. Product images are stored in a separate table called product images. The actual image files are not stored directly inside the PostgreSQL. Instead, images are uploaded to Cloudinary as we have already told for millions of times, and the database stores only the Cloudinary image URLs. This is a better design because media files can be large, while the database is better suited for structured data. The product table stores the product information while Cloudinary handles media storage and delivery. Coming to logistics, the main thing here is the logistics companies. Each logistics company is connected to one user account through a one-to-one relationship. This means the company has login access like a normal user, but it also has a separate company profile with business information. The logistics company stores company name, registration number, tax ID. The most important thing here is the domain is logistics requests. This table represents delivery orders. When a buyer requests delivery for a product, the system creates a logistics requests. It stores the product ID, buyer ID, assigned logistics company's ID, pickup coordinates, destination address, estimated price, estimated delivery time, notes, and status. Of course, some of these features are planned for the future. The logistics reviews table stores buyer reviews after delivery is completed. And finally, logistic documents table stores verification documents uploaded by logistic companies such as logistics handles company profiles, branches, documents, delivery requests, route-related coordinates, delivery statuses, and post-delivery reviews.
So, hello again, and we're back here. I guess this video was informative enough for you in order to understand the whole process that we did, the whole journeys that we've covered to come at this to this point. And our aim was not just to show what we made. Our aim was to show how A-Caravan evolved, how actually we evolved while trying to implement the idea. Actually, it was a spark of an idea and it grew into something big. It wasn't something that we made separately. Of course, we had some parts that we divided between us. Me, for example, I implemented the mapping system, and also it was my responsibility to talk to end users. I went to Shamkir to make interviews. I experienced the whole thing about marketplaces, Azerbaijani marketplaces, bazaars, in order to understand the problem issue. And I guess my friends are going to talk about their implementation and what their contribution was, and then we're going to just wrap up this video.
Yeah, for my side, my contributions were mainly developing the application. So I developed the front end first of all of the application and then contributed to its backend. There were a lot of issues with this, especially implementation of the mapping after Shamil created the logic of this. It was total mess, but we somehow managed this. Then I hoped Wagif with web panel. I also wanted to deploy our application. I deployed the database of our application to Neon and wanted to do the same with the backend to the Firebase, but unfortunately we didn't have a lot of time to do this. I also created the APK file of it, and I downloaded to UpDown. This is the service where you can download anything, applications for the Android phones mainly. It's not available unfortunately for iPhones. And unfortunately, we at the end of the day decided to delete our application from there because it was not suitable. We should work a lot more for the future. And I guess this is the whole contribution from my side, and Vagif will continue.
My contribution consists of making database architecture, including ER diagram and some queries inside of the databases, and I made also some modifications in web panel and logistics panel. That's all from my side.
So basically, despite the fact that we're actually talking about the things that we told, Namik helped me, I helped Namik, Wagif helped us both. We were actually as one whole. We were all working together, and that's why coming to contribution, it doesn't make that much sense for us. So our contribution, if to be divided out of 100, is going to be 33.33 for each of us, and the remaining 1% is going to be just a giveaway. I don't know.
I would not say that it's a giveaway. It's for you, Mr. Farouk, basically.
Thank you very much. By the way, thank you very much, Mr.
Thank you very much.
You supported
Yeah.
us, you supervised us, you're one of the best teachers that we ever see.
You gave the idea of filtering, basically, of map filtering, what's more specific. This was a great idea, I think, and the users also liked it. So, yeah.
Yeah. So basically, thank you very much for your attention. Thank you very much for the semester. And we hope you enjoyed the video. We'll see you later. Bye bye.